the surface development drawing phases the 3D model visualization. The view projections in AutoCAD basis CAD software. And we will discuss how to generate the general arrangement, including the bill of material, balance, dimensions, and tables for one of those equipments, adding cladding and welding details in your drawing. Here, the first equipment, which is this horizontal vessel, according to Division 2. Here we consumed around 4 hours for data extracting. As mentioned, data extracting means getting the dimensions of each element to use it in SEG software. Like, for example, if you have a can, we will get the inside diameter and the thickness of this can, the length of this can, the longitudinal welding line orientations. If we have a nozzle, for example, the nozzle size, nozzle location, orientation, the schedule of this nozzle, the connected flange rating, facing, all of that. That's the meaning of data extracting from your drawings. We consumed around between 3 and 3.5 hours to generate the 3D model of this equipment by using SEG software. And here, as you can see, after modeling this equipment, by using SEG, you can figure that each detail, you can get it from the 3D model. So if you have, for example, a clash which is not clear on the 2D drawing, on the 3D model easily you can get it. Here, like the clash between the nozzle support rib and the saddle, and here the support rib with the forged hub. Something like that, you can get it easily from the 3D model. And you can make an interior check and exterior check for the elements for your model. Okay, and as you can see here at SEG software and the generation of the 3D model after data entry in SEG 3. And for your information, this video for assembly, it's speeded up 20 times to save your time. Okay, as you can see, each element created automatically and assembled to the vessel final assembly in seconds. And you can imagine how much time you will save in case of making the modeling manually instead of using the SEG software and the automation of the 3D modeling for elements. Here, finally, let's speed up this video a little bit up to here, and you can easily check the clashes if you have any clashes in your model or not. Now for the second vessel, which is a vertical vessel according to ASME Division 2. Here we consumed around 3 hours for data extracting, as mentioned, getting the dimensions of each element, and we consumed around 2.5 hours to generate the 3D model over SEG software. And here you have the 3D model for this equipment, including the available items in SEG software. In both models, no manual items or items created by the user manually. All of those items created by SEG software. And on the next slides, inshallah, we will discuss how to add a special or non-standard item which is not included in SEG library, and we will discuss the different ways to create them. Here, as you can see on the 3D model, we have an internal vortex breakers, the internal rounds. You can make a section inside the model to check if you have any clashes or not. And now for the from SEG itself, let's create the 3D model from scratch. As you can see here, the elements fireproofing, skirt opening, access, and vent, all forged nozzles, the manways with the detailed davit and with hand grips, bolts, platform supports, All of that generated by SEG software in minutes. Now let's generate the holing of the nozzles by using the holing tool in SEG software. As you can see, the holing of nozzles generated automatically for nozzles, and it's working for some of the standard shapes of nozzles. For example, if you have a nozzle with a forged hub with lips, okay, you may need to make this hole by using the Autodesk Inventor features. Okay, now let's discuss how to add a non-standard item to the 3D model which created by SEG software. Actually, we have different ways to do that. The first way, which is creating a new part by using Autodesk Inventor 3D model, 3D modeling features. Okay, and we will discuss that on a separate slide. Modeling, modifying on the 2D drawing itself, like modifying in AutoCAD by making sketches on views. Customization over an SEG part, and each one of those we will discuss it in a separate slide. Using SEG helper library, and requesting adding new items in SEG library. For example, if you have a special part and you would like to add it to SEG library, you could ask SEG development team to add this part to SEG library, and in that time you can use it from your side, from SEG itself. Requesting a special automation outside SEG library. Now for the first option, which is creating a new part by using Autodesk Inventor 3D model. Here we have this support on the horizontal visit in your model. Actually, this type or this configuration of support is not included in SEG library. So how to create it? We will use the 3D modeling features of Autodesk Inventor to create this part. So we will make a 2D sketches to identify each part dimensions. Like here for the wear plate, we define the wear plate thickness. After that, we will make the support clip and modify the dimensions of this clip, like the height, the bottom width, and the top width, which is 160, like that. After that, the tilted angle for this line. And let's add the holing inside this plate as a 2D sketch. We are doing now a 2D sketch only. After that, we will convert it to a 3D model and add it finally to the visual assembly. Now, let's define the location of this Eclipse from the visual center line. Define the wear plate width. Okay, and by making some modifications on the 2D sketch, like closing the sketches to identify the area of the wear plate by adding arcs and lines. Now we have this sketch, and we will create the wear plate for this part. Here we have this wear plate, and now let's add the stiffening clip or the clip. So let's make a work plane with a defined location. And let's make an extrude, give it a thickness. Okay, and now let's add the holes on this clip by using the holing feature. So let's add the hole locations. First, select the holes and define the hole diameter and add it. Now let's add the stiffening rib to this clip. Okay, so let's define a work plane at the end of this clip. After that, create a sketch to identify the dimensions of this clip. Okay, so as the top, the width is 100 millimeters. This edge is 20 millimeters. At the bottom, it's 15. And adjust the length equals the length of this clip. Now let's give it a thickness. And now you have this stiffening support for this platform support or piping support. Let's add a fillet to the end of the weir plate. Finally, let's save this part and change the material to be with the density of steel, so you can get a correct weight for this item. And now let's add this clip to the vessel assembly. So let's import this part to the assembly and define the location for this part from the tan line. Okay, so by using the Autodesk Inventor features, you can generate any shape or any mechanical part you would like to generate, because that's the power of the CAD software. Okay. Now let's discuss the second way to modify an item or generate a non-standard item in your drawing, which is modifying the 2D drawing like in AutoCAD. Here, for example, we have a projected view for the equipment. You can select the view itself and start creating a sketch like in AutoCAD, make lines, adding dimensions for that. But actually, we don't recommend this way, because during the calculating the projection of views on the other sides, you may make something wrong or forget something, as we will discuss on another slides. Sometimes the draftsman may forget or make something wrong during the calculation of projection views of the vessel. So we don't recommend that way, but you can do it, which is making a 2D sketch over the 3D model on your drawing, like in AutoCAD. Another way to modify, which is customization over an SEG part. For example, here in your model for the vertical vessel, we have a platform clip at the top of the head. Okay, and actually in SEG software, this end plate includes 4 holes only. The option is for 4 holes, not for 8 holes. So if you would like to modify on it, actually you can open this part and add the new holes and modify the feature by hand. It will not take seconds to make your modification to make it suits your requirements. That's the third way of modifying on SEG. Now, another option to add new items or non-standard items to your model by using SEG helper library. And here we will discuss 2 options. The first option in SEG library, which is SEG helper for the pre-built assemblies. Here you have some pre-built cranes, so you can use it in lifting procedure. You have some saddles for transportation, saddles for tilting, saddles for centric reducer or eccentric reducer, and some different sub-assemblies you can use them for model. In that case, we will select the transportation track to make a transportation 3D model for the equipment. And from here, let's select the location of the project, and let's export this item. And from here, let's open the transportation track assembly. And from the iLogic browser, you will find a form to modify the dimensions or the orientation of the truck, the length of the truck, and many other options you can control it. Now let's create an assembly includes the transportation truck and the horizontal vessel to prepare a 3D model for the transportation assembly or transportation drawing. So from here, let's make some constraints like mating the truck top surface to the saddle base plate bottom surface. And from here, let's remove the end of the truck, change the length, and increase the number of wheels for this truck, extend the length of each side for this truck. And now you have a 3D model after adjusting some dimensions. If you would like to add a wiring or something like that, you can do that, or some wooden blocks below the saddles. Anything you can do it for the 3D model. And finally, you have a transportation 3D model for your equipment with the truck, and you can use that in animation, simulation, many things, and you can figure that it's generated in minutes. On the other side, you can use the SEG library to generate some items which included in SEG library, like bolts, nuts, hot roll sections. For example, if you would like to create a flange, you can use the external library of SEG helper to modify the flange rating, size, and facing from raised face to RT joint, change the size, change the series if you have a size over 24 inches, like that. So you can use those items, pre-built items. For example, if you have, if you would like to study the pinhole diameter, if it suits the standard shackles or not, just from SEG library, select the shackles that you want, that you will use it, and change the load of this shackle, and you will have the dimensions of this shackle, and you can assemble it to the final model to check if the pinhole diameter of the lifting lug suits the saddle, for the shackle dimensions or not. Another way to add new items to SEG library by requesting from SEG development team to add those items to SEG library. For example, we did that 100 times, and that's some samples from requesting orders from our clients. This type of lifting lug, one of our customers asked us to include it in SEG library. So now it's available, so you can, any user can select it, and when he select the lifting load for this lifting lug, automatically he will get the dimensions according to this standard spec. For example, here if you select 35 tons, for example, you will get all the dimensions for this lifting lug automatically. And if you would like to modify the dimensions manually, you can do that. We give an option for the user if he has some manual calculation or mechanical calculation for this lifting lug, he can modify over the standard dimension. Another request from one of our clients for the spherical tanks, which is generating a support legs for the spherical tanks based on their standard. And here, as you can see, the modeling of the spherical tank and the support legs. And in detail, we will here, for example, if you open or make a section on this support leg, you can figure that how much detail inside, like stiffening ribs inside this support leg based on their standard. And you can figure that each sheet metal plate, you can get a development for it. So it's easy to generate a sheet metal development for each part or sheet metal part generated by SEG software. Another option, which is requesting a special automation outside SEG library, like one of our customers asked us to generate a platform. So this part, it's outside SEG. It's completely coded and modeled in Autodesk Inventor and by using the iLogic tool and VBA. So from a form, you can make a modification for your structure, changing the length with, for example, in this case, the number of pumps, the spacing between pumps. So our team can develop something special for you. And the same for the drawings. You can make an automated drawings for your model. So it will save a huge time if you make the same thing with different dimensions each time. So you will save your time in case of using the parametric modeling and automation tool from SEG development team. Okay, so after that, why we are using SEG, why SEG uses a CAD platform like Autodesk Intent? Well, as mentioned from the previous slides, you can generate any mechanical part by using the CAD software. And after that, you can use this model in the finite element analysis. You can use it in dynamic simulation, animation, rendering, and many things. You can gain the benefits of the CAD software in modeling and detailing. Besides that, the 3D visualization and rendering for the 3D model that you have, so you can check clashes, anything easily from the 3D model. You can export the 3D model or 2D drawings to many different extensions to suit AutoCAD, to suit SolidWorks, to suit BricsCAD, any other CAD software. Okay, for example, let's ask a question. If you would like to add a simple part like a nameplate to a BV Elite model, can you do that? Can you add a nameplate on the 3D model in BV Elite? Okay, or a platform Eclipse in detail, or fireproofing Eclipse on saddle? Can you do that? Actually, it's impossible. Why it's impossible? Because BV Elite architecture is not support that. It's for calculation. But in SEG software, the architecture of our software focusing on that purpose, which is modeling and detailing. And we are uses a platform, CAD platform for that purpose. So you can generate any mechanical part, even it's not included in SEG library. Now, from our model, let's discuss how to make a saddle detail like that detail by using SEG software from the model that we already modeled it for the horizontal vessel, and how much time we will consume to generate this detail, and how we can modify it by adding the fireproofing details. So now let's come back to the model. Here we have the 3D model of this horizontal vessel, which is created by SEG software. And now let's come back here to SEG, and you can figure that you have the tree, which is include the items of this equipment. And here you can select the saddles, and here's the available types of saddle. And here's the dimensions. And now we would like to generate a detailed drawing for the saddle, like this drawing. Okay, so how we can do that from SEG software? Now let's check or select the saddle from the tree. And from the shortcut menu here, you can select drawing and select create drawing. Now you will get this dialog box. And from this dialog box, you will need to select some options, like if you would like to add a bill of material, design data, or something like that. And we will discuss each one in detail. Now let's select the size of the drawing. So the first, from the first tab here, you can select the size of the drawing. So let's select A2 size. And from here, you can select the location of the title block. Okay, so you can make the title block at the top right or the bottom left. Okay, so you can change the border, title block. You can rotate the drawing itself, make it portrait or landscape. That's on the first tab. On the second tab, you will select the required views for the saddle. For example, here we have, let's open this saddle. And from here, we need to make 3 views or 2 views in our drawing. For example, here we have 1, 2, 3 views for this saddle. Okay, so from here we can select 2 views or 3 views. So let's select 2 views, for example, and add a spacing between the 2 views. So we will generate 2 views for this saddle. Let's generate that view and that view. After that, we will make a section here to show the holing dimensions. So here, let's select the orientation of the elevation view. From here, for example, if you would like to make that view is the elevation view, okay, so you will need to select a front view of this saddle to make it the elevation view. So from here, let's select it front view, okay, and from here, let's keep those dimensions as they are, and from here, let's change the scale of the saddle a little bit, and all of that we can modify it after generating the drawing to adjust the scale and the location of the view. Now let's add a bill of material for this saddle. And for the notes, if you would like to add some notes, you can modify on the standard notes, or if you would like to remove them, just remove this checkbox. And for the welding details, let's select some details from SEG welding library. So for example, let's select this detail and that detail for the web. And now let's save that. Okay. Now for the title block border, let's add this one as a sliding detail, sliding saddle detail. Okay. And give it this drawing document number, like UG example. And from here, let's edit the revision table. It's revision 0, for review. Okay, and prepared by, checked by, for that, and click save. Now you can add some empty rows to the revision table. And from the design style, we will discuss this tab in detail for the general arrangement drawing. But right now, let's select one sheet only for this one and click on save. Now let's click on generate drawing to start generating the saddle drawing. Here, as you can see, we have 2 views for this saddle. And actually, we need to change the scale a little bit, make it a little bit smaller. And so from here, let's select the drawing again. And from drawing view, let's change the scale a little bit. So let's make it 20. And from the X location, let's make it on, let's say, 22. And okay, and create drawing. So as you can see, the scale of the saddle modified here. Now let's add some dimensions and balance for this saddle. Let's add a center line for this one, and let's measure the height of this saddle from the center line to here. Okay, add the length of each rib by that way. Okay, if you would like to add spacing between ribs like that. So adding some dimensions to your model to make it make sense. And here the total length of that one. Let's add the thickness for this weir plate. Adding some dimensions on the other side. Let's move this text a little bit here. And if you would like to add some dimensions like the thickness here. Sorry. Like that. Okay, and now let's take a section on this the base plate. So let's take a section along this one to add the dimensions of the saddle. So from here, let's select automated center line and select holing like that. So we'll have center lines for the holes. And from here, you can add the dimensions for blades like that. So actually, a drawing like this may take between 5 or maybe less than 5 minutes to generate based on the 3D models that you have on Autodesk drawing model. Okay, and you can add a welding details, like adding, for example, you can add a weld details by using that option. For example, let's add a fillet weld from the two sides, like that, something like that, or adding a fillet weld which indicates blade and the shell. So it's a round weld like that, and it's, let's say, 14 millimeters, for example, something like that. So you can add something like that to the saddle assembly. Now let's discuss how to add something like the fireproofing Eclipse on the saddle. So it's not a standard item. It's not included in SEG library for saddles. It's included for shell, head, and core. So you can add, for example, if you select the shell, for example, and from the elements, from the external attachment elements, you can figure that you can add many different items. Some of them, like grounding lugs, fireproofing Eclipse, it's available for parent items like head, shell, nozzles. But for saddles, the Eclipse are not available. So how to add something like that to our drawing? Here we have this saddle. Okay, so you can use many different options, and let's discuss one of them, which is using SEG library. For example, let's open SEG helper library, and from the accessories, you may find here some options for the some items like adding bolts, nuts, J-bolts, U-bolt, crossbeam shackles, some items for nozzles, hot rolled sections for some standards, tie rods, sealing rods, and transportation wiring or lifting wiring. So, for example, let's from the accessories, let's select a rectangular washer and let's open it here. Okay, so we have this washer, and you can define the dimensions of this washer. For example, let's make it 40 millimeters by 40 millimeters, and the thickness, let's keep it 6 millimeters, and the whole diameter, let's make it 10 millimeters. Let's define the material of this item and the item number. Now let's save this item from SEG. So from the assembly tab, let's save this document and come back here. So let's add an extra part and name it as fireproofing clip. Okay, and let's come back to the saddle simply here, that one, and let's import this part, which is the fireproofing clip, this one, for example, and make a constraint for this part to make it locate on the side of the outside rib. Define the location for the first one. Make it on 300, for example. The same for the second one. Like that. Make an offset from here to 100 millimeters. And for the other side, like that. And now you can make a pattern for both of them, like that, along the side of this one and flip the direction. Make them 5 with spacing like that. Okay, so something like that will not take a minute from you to fill that on the 3D model. And when you come back to the drawing, again, you can figure that you have the Eclipse that you add here in your drawing. So it's just minutes to modify that. Now let's add some balloons for the support saddles. So from here, let's select the item number balloon. So if you select, for example, that side and select parts only, you will get the item number for each item like that. Okay, so those items or that number related to SEG bill of material. So where is its SEG bill of material? We will discuss that in the general arrangement drawing, but in a quick view, if you open the bill of material here, for example, you will get a detailed bill of material for your equipment. Here, as you can see, here we have a list for all items for this equipment. Okay, and you can extract this bill of material in Excel format. Okay, but now let's check the item number 71. Okay, so here if we go down here and select item 71, as you can see, it's a rib plate. Okay, and here the length of this rib plate and the width of this plate and the thickness. So that's the description and the technical characteristics for this element. Okay, so as you can see here, you have the length of this plate, which is 1,597. So if we check that, here you have the length of the plate. Okay, and here the width of the plate. You come here and check the width of this plate. You can figure that in with that width, and finally the thickness of this plate. So you have a detailed description for the items here. Now let's check the wear plate, for example. It's item number 75. Okay, so let's come back to the SEG bill of material and check item number 75. Here you have the length of the wear plate, the width of the wear plate, and the thickness. So actually, this value is the delivered plate, or it's the development or the flat pattern for this plate. Okay, so how to check that? For example, here let's open this wear plate separately, and let's add a flat pattern detail for this one. So from base view, let's add this wear plate, but in that time, let's add it as a flat pattern. Okay, so as a sheet metal part. Okay, and let's find the scale. Be like that, or 20, 1 to 20. Okay, and here we have the development of this wear plate. So let's check the length of this wear plate and the width of this one. As you can see here, that's the length, which is 6597. And it's here the length of the plate 6597, which is the developed plate that I mentioned before rolling. Okay, and here's the width and the thickness of the plate. Okay, now let's take this drawing and let's close those opening documents, and let's come back to our presentation again. Here, so we discuss in this slide how to generate the saddle drawing and how you can modify over it, how you can get a sheet metal development for a rolled plate like the wear plate. On that point, we will discuss the forged hub detail creation by SEG Software. Actually, during the data collection from your drawing, which is extracting data to start creating modeling over SEG Software, we found that for the forged hub with lips with an offset with helicide option, we figured that the width of the insert bed or the lip of this forged hub, you give it two different values on the two sides. Okay, in SEG Software, we give a one value, and this value is a constant value around the hub itself. So if you take a section in any side on this hub, you will find this value is constant in all sides. Why we are doing that? Because the actually, I think it's the right way to make it, because the fabricator, when you send him a drawing for a forged hub, and he will make a fabrication for this one by using CNC or by using forged weight or something like that. If this value is a different value, you may need to submit all values around the hub. For example, in that case, here you have this value on that side and another value on that side. So which is the values on the other side, or in the perpendicular side here or there? But here in SEG, for example, if you open one of those hubs, for example, let's open this hub detail. Okay, as you can see here, the width of the hub in all sides here, that area, equals that one. So it's equal around the hub from all sides. Okay, so that's an option. And here we would like to discuss, after creating the hub by SEG, you can make a welding preparation for this hub, like making a chamfer, for example. So if we make a chamfer and select the chamfer option from here by defining a distance and angle, and let's define this angle as 20 degrees and make the distance as 94. So let's select this one and select this edge, and you can figure that you can make a chamfer with a defined value, which is 20 degree, for example, or 70 degree. So you can change the value of the chamfer around the hub in all sides, like that. So you will get a forged hub by that way. Okay, and here, by using this forged hub 3D, you can generate a J coding for which used to generate the machining on CNC machines. So by using a CAM software like Autodesk Inventor CAM software, you can generate the J coding which suits the machining CNC machines to fabricate this item. And one more important point here, for example, if you have an equipment after 5 or 10 years, you have a repair in this equipment, okay? And one of the forged hubs need to be replaced, okay? If you depends on just 2D drawings, the fabricator may make something wrong. But if you give him a 3D model for this forged hub, you will be sure enough that you will get the same forged hub that you fabricated from 10 years, because it's the same part and you will get the same J coding for that part. As mentioned on the previous slide, here we keeping the width of the lip equal in all sides. Okay, one more point we note it for the forged hubs on the head, okay, which is located on the center line of the vessel. Actually, as all of us know that the hub height measured from the lowest point at the hub. Okay, so in that case, for example, it's a helicide nozzle on head. So the hub height measured from the lowest point on the hub. In the head case, if you have a forged hub on the head, and it's located on the middle of the head, okay, on the vessel center line, as you can see, the head not completed to the end. We have a cut here. Okay, so we have a cut for the nozzle here. Okay, so the highest point of the hub measured from that point, which is the meeting between the hub and the outside surface of the head, not an imagination point. Here in this drawing, you can figure that the hub measured from not a real point. This point does not exist exactly. The exacted point, or the real point, which is located on the head, is that head. So the height of this hub measured from the minimum point or the lowest point on the hub. So that's the lowest point, because this line is a straight line. It's not an arc like that, because this head has a cut. We have an opening here. We don't have this arc. Okay. One more point we would like to discuss, which is surface development faces the 3D visualization. Here in that drawing, you can figure that you locate the opening locations, the welding lines, all of that on your drawing. And actually, this drawing shows the outside hauling, or the outside lines only. But if you have a large diameter vessel, you may have to make another one for the inside. You cannot make both of them on the same drawing, because you will get different total circumference for the inside and the outside. So if you have inside attachments inside this vessel, you cannot locate it on the same view. So how to make 3D visualization and how to import a 3D model from SEG and to this inventor here. For example, you can export your model in a PDF. As you can see, it's a PDF file. You can export your 3D model in a PDF file, and you can make views for your client to show him if you have any clashes and you request changing a location or orientation for a nozzle or something like that. So here you have as a default view. For example, we make a view like that view, which indicates the clash between the stiffening rib of this nozzle with the this welding line. Okay, another clash between the this rib of the nozzle support rib with the whip of the saddle. So you have a clash here. Another clash here between, if you can see that, you have a clash between the nozzle rib and this pipe. Okay, actually, we used the mentioned details here, which is indicates that the stiffening detail for all 2 inches nozzles, and it's constant for all nozzles. So if you apply it and add it to the final model, as you can, if you take a look to the drawing here, you can figure that it's not indicated on that drawing. Okay, so you cannot detect if you have a clash here between the saddle and the rib. And let's come down to the sheet metal development. And here on this drawing, no indication for the stiffening ribs of the nozzles. But here on the 3D PDF model or on the 3D model in Autodesk Inventor, you can detect that easily from the 3D model, like those stiffening ribs. Here you have a clash between them. But if you would like to send something to your client to discuss with him to change some locations, some orientations, or change the rib contact angle or the location of the rib, something like that, you can do it easily from the 3D model. Another clash here between the rib and the saddle. Another clash here between those nozzles and the welding line of between the head and shell and with the support rib. Another clash here, another clash here, and you can make a section for the client to check the interior of the vessel on the PDF, so he can check the interior items if you have demister, if you have internal support, something like that. By that way, you can check the 3D model. Okay, now we discuss the surface development phases 3D model and how the powerful of the 3D model, which give you the ability to check the clashes easily in your model. One more thing we would like to discuss, which is view projections. Okay, in this drawing, as you can see, the welding line on the head takes this convex direction, but actually it's a straight line. So some views from the draftsman, he may not calculate the projected view in a correct way. So it may affect on your drawing. For another example here, for this welding line on the drawing, which is LS1A, it's located at the top of the vessel. But actually on the other side, the orientation of this line located at the bottom. Okay, so if you have a nozzle at that side, by the way, no nozzle, it's on the other side. It's on 27 degrees, not on the 90 degrees. We haven't a nozzle on this shell course. But if you have a nozzle, you will not detect if you have a clash between this welding line because it's located on another location. Actually, it should be right here. So something like that on 2D drawings, it may take place because the draftsman or the engineer can forget that or missing something when calculating or getting the projection views for the vessel. Okay, now on that slide, let's discuss how to generate the general arrangement drawing for the equipment, and how to generate the bill of material of this equipment, how to make more than one sheet, how to add a balance for the equipment, and finally, if you have any questions regarding that, we can discuss it. Okay. Before going to the drawing, we need to discuss some points regarding the bill of material. Here, as mentioned, you will get a complete and a detailed bill of material for your equipment. As you can see, here you have the total weight of the equipment. It's more than 300,000 tons. Okay. And the total number of items here, and the description of each item indicated on that list. You can export this bill of material in Excel format. So, for example, let's go to the folder of this project and export bill of material in Excel format. So, when you click Save, now it's exported. If we come back to the folder of this project, so let's minimize that. And here you have the bill of material of this equipment. So, as you can see, you have a list, a detailed list here for the equipment, okay, which include the total number of elements and the total weight of the elements, and a detailed description for each element. So let's take a look, a near look from here. Here you have a hemispherical head with inside diameter and nominal thickness, minimum thickness after forming, and the cut length. Here you have different shell courses, each shell course length and width and thickness. And here the all seamless pipes, all flanges, or forged ups, all of that, a detailed bill of material for each element. Okay. Some other tables available here, like the nozzle load, nozzle table. Here you have a list of nozzles for your equipment. Like this table includes the nozzle tag, so you have a list for the nozzle tag, and the nozzle surface, nozzle size in inches, the outside diameter of the nozzle, orientation, thickness, scalable, flange plus and rating, flange facing, and if you have a blind, you will get the rating of the blind, the facing of the blind, the external projection from the vessel central line will be indicated here, and the welding style and dimensions of the weld. Okay, now for example, if you would like to indicate the size of nozzles in NBS or DEN, from the equipment setting, you can change between the size of the nozzle to be in DEN or NBS, and you can make a mix between that, like you can make it NBS and between brackets the size in DEN, and you have many different options. For example, if you would like to make it NBS and between brackets DEN, and if you click on Save, now if you open the nozzle table, you can figure that here the size of this nozzle. Let's take print screen because I think it's not clear in your side. So let's come near here. As you can see, here the size of the nozzle indicated in two ways that we select, which is the size in inches and size in DEN. All of that you can figure it here like that. The size could be mentioned like that. And besides that, you can change the units in a bill of material. If you would like to make it in decimal or inch, okay, so you can make it in millimeter or inches, or you can make a mix between dimensions. Like for example, if you would like to make a mix between millimeter and inch, like that. And if you open the bill of material, and if you check the format of the characteristics of the element, let's take a print screen. And when you take a close look here, for example, as you can see here, the inside diameter mentioned here in inches, in millimeter and inches, and the same here for the thickness, minimum thickness after forming. So you can extract the data in your bill of material in many different ways. Okay, now let's make everything come back to the original option, which is NBS here, and make it in. But by the way, you can make if you select it in decimal, you can make it with a fraction. So you can convert the value in a fraction value. Like if we save this and let's open the bill of material again, and let's take a print screen here. Take a look here. So you can make a value in fractions like that. So it will be in millimeter, and in case of inches, it will be in fraction. You have a foot, and here the inches, and here the fraction of the value. Okay, so there are many different options to describe the dimensions or the nozzle. So let's come back again and make it in decimal and select millimeter and click on save. Okay, and here there are some other tables like nozzle load table, coupling table, and other tables like that. For example, if you would like to add a nozzle load, you can do that on SEG. It will help you to export it in your drawing as a nozzle load. So let's check something like that. For example, let's add a nozzle load on this nozzle. So let's select M3, which is a manhole on the right head or on the left head. And from this checkbox, you can activate the nozzle load. And from here, you can add load on this nozzle, any values you would like to add. And if you open the nozzle load table, automatically you will get a nozzle load table, which includes the values that you mentioned in that nozzle. Another nozzle, which is N1, for example, let's add some loads for this one, like that. And here, if you open the nozzle load table, you will find that. There are some other tables like the pipes table. So you will get a list for all pipes in your model, okay, like that. And you can export it in Excel format. A nozzle orientation table, so you can get an orientation for all nozzles in your model as you defined it. A fitting table if you have elbows or reducers or something like that. A list of gaskets, list of flanges. So if you have any flanges, it will appear on that table. Now let's discuss one more point before going to the general arrangement drawing generation, which is if you would like to add your own border and the title block, because SEG uses its standard title block. So you will find videos talking about that on our channel, but here we will mention that quickly. You can import your standard drawing. If you have a standard drawing, it should be in IDW extension. So you can import it from here and give it a name and define those dimensions, which is the border width from the sides and border width at top and bottom, the title block width and the title block height. After that, you can include this drawing as a reference drawing, so you can use it in your project instead of SEG standard border. Okay, so that's the point if you would like to generate a drawing in your model. Now let's generate a general arrangement drawing for this equipment. So you will need to select the equipment node from the tree. After that, right-click and select create drawing from the drawing list here. And from here, as mentioned on the saddle, you can select the drawing size. Okay, so let's make this drawing as A1 size. And from here, let's select two views and define the spacing between the views with centimeters, 4 centimeters between the elevation view and the side view. And for the elevation view, let's discuss which view we would like to make it the elevation view. For example, let's select the left view as the elevation view. That one will be the elevation view. So let's select the left from here. And from the style options, you can select the first option, which is all hidden lines will be visible. Okay. Or the second option, which is hiding all hidden lines. So the visible lines only will be visible in your drawing. And here you can add a shading, which is the color on the 3D model. Now let's define the location of the vessel and define the scale. And from here, from the tables that we would like to export it in your drawing, for example, let's export as a bill of material, let's export as a design data, the nozzle table, and the maximum allowable nozzle load table. And from nodes, if you would like to add other nodes, you can add it from here or modify on the current nodes or delete those nodes and add your nodes by importing the nodes from an external Excel sheet. And from the welding detail library, you can select the required welding details from SEG library. So let's select those details. So from here, let's remove those and select.
Hi Ahmed, just a quick one in this. If at all there is a non-standard welding we want to add, is it possible as well?
Yes, I will talk about that.
No worries.
I will talk about that during the drawing.
No worries.
Creating. Here, so you can select welding details from SEG standard library. Okay, and we will discuss how to add other welding details if not included in SEG. As during this, the creation of the general arrangement, we will discuss it. You can add a client document list. For example, if you have a process data sheet, mechanical data sheet, some specs, you can include that as a document list if you would like to include a list of the client. And the document list, like if you have a mechanical calculation, you will submit a mechanical calculation, you will submit a general arrangement, nameplate detail, saddle detail, manhole detail. So you can make a list for drawings that you will submit here. Okay, here from this tab, you can define the drawing title like general arrangement and the document number, that for example. And from here, let's define the revision and now let's add some empty rows here. And at this tab, we mentioned that we will discuss it in the general arrangement drawing. We didn't discuss it in saddle because here it's mainly we can use that if you have a huge vessel and a huge bill of material. So if you would like to make a sub sheet for the general arrangement, make the general arrangement drawing include 1, 2, or 3 sheets, you can do that. So you can separate some tables on another sheet. For example, here in our case, we have a huge bill of material. So if we put it on the main drawing, we don't get enough space to add it. So we may separate the bill of material on another sheet. To do that, you can select the design to option, which give you the ability to control or add another sheet and to control the size of the second sheet. So the second sheet size, we will define it as A2. And for the first sheet, we already defined it as A1. So the second sheet will be A2. And from here, you have the tables that you will export. One of them is the bill of material. And from here, you can move the bill of material table to be exported on the second sheet. Okay, so let's click on save, and now let's create the drawing. Okay, here that's the second drawing sheet. As you can see here, that's the bill of material filled automatically, and you can imagine how much time you will consume to generate this bill of material manually by the traditional way, how to fill it manually, and sometimes you may miss some items. Here in SEG, those tables will be filled automatically, and it will placed on the drawing on the right place. Here we, as if you take a look to the drawing tree, you can figure that we have a sheet 1, which is include the after filling the bill of material and putting it on the right place, automatically we will SEG will move to the first sheet, okay, to modify the adding the other tables like the design data table, nozzle table, and the views of the vessel and the welding details. As you can see here, SEG filling the bill of material. After filling it, the size of the table will be modified to suit the drawing size. Here, the data filling is done, now done. And here, that's the first sheet. Okay, now let's move to the first sheet. Here we have the first sheet. Now the welding details that we select will be created on the drawing. Okay, now I think we done. And as you can see here, the tables that you have, and that's the revision table that we fill. And here the design data table for the equipment, the notes table, and here the client document list and the visual document list. Here the nozzle table, which includes the nozzle size, nozzle service, a tag, nozzle tag and size, and here the outside diameter, thickness, and all information about this one. Now, as you can see, we need to modify the location and move this table to another place. Okay, so let's move this table right here for the nozzle load, for example, and let's change the location of this view from drawing. So from here, let's come back to the drawing, and from the drawing here, let's modify the location of the view. So we could move this view a little bit down here. So let's change this one to 26, for example. So the location from the Y location from the bottom to 26 centimeters from the bottom. And I think the scale is okay. And we could move it a little bit to the right side. So, and from here, create the drawing again. And now the view will be updated like that. If that's enough, it's okay. And if you would like to make another modification, like move it a little bit down again. So let's make it 23, for example, centimeters from the bottom. So we can modify that by that way. Okay. Now here we have the general arrangement drawing for this vessel, and here we have the bill of material. As you can see, the bill of material it's extended out the vessel, so you can make a split here. So, for example, if you select this table, you can make a split table from here and move the splitted table down here. Okay, like that. And you can make another split, or you can extend the table width like that and extend the width of that table a little bit. That. Okay, and move it down here. Like that, so it will be free from the top like that. Okay, so let's come back again to the general arrangement drawing. By the way, on the bill of material, look, you can flip the arrangement of the bill of material if you have many options to make the arrangement start from top to bottom like that, and the arrangement of items start from to bottom, or you can make it without heading, or you can make the heading start from bottom to top like that we have in our case here. Okay, let's come back to the vessel. And as you can see here, the smoothness of lines, and you can get everything you modeled it on the views automatically. Any change you will make, it will be reflected here. So let's add some center lines, okay, for the vessel. Let's add a center line for the vessel. Let's add some other center lines for nozzles, saddle. To add the to show you how to add the location of nozzles on the drawing. And from here, let's add a center line for this nozzle to measure the projection and all of that. And now let's add a datum point. So by using this type of dimension, we can add a datum line. So the datum line will be at that point. So for example, if you would like to measure a distance or the location of this nozzle from here, you can measure it by that way. So let's add some center lines, let's say for this trunnion for those nozzles, like that, for that hole, or for this nozzle. Something like that. You can add a location for the nozzles by that way. So all of them will be located on the same side. And by the way, you can add a balloon for the nozzle tag. So for example, if you would like to add a tag for this nozzle, you will just select this nozzle and select parts only. And from this list, select nozzle tag. And now you can add a tag for the nozzle by that way, like that. Another nozzle, let's select this forged hub. So in seconds, I think you can not seconds, in minutes, you can do that and complete a detailed drawing. So, and you can hide the origin point if you would like to hide the origin point. So we can hide the origin point from here. And if you would like to measure the projection of the elements from the seam line that we have, add the straight flange length, add dimensions for the shell plates. So for example, here we have a shell plate for that one, another shell plate, like that. So from the 3D model, you can modify the dimensions to suit your requirements. And here one more point regarding the, we come back to the slide here from the points here, how to add a clad to the 3D model and how we can add a welding detail to our drawing. Okay, so let's discuss this point. Here in SEG, you can add a cladding for the main elements. Okay, right now, not for the child's like nozzle on the 3D model, but you can do that on the drawing easily. And we will discuss that inshallah. Here, for example, if you select this can, for example, which is can 1, and from elements, you can add internal attachment for this can, which is a clad. So let's add this clad, can 1 clad. Okay. And from here, you can select if you would like to add this clad as a separate part. So it may be developed for you as a sheet plate. So you can consider it as a separate part, or it will be weld overlay, or by another way, you don't like to mention it on the bill of material. You just would like to get the weight and get the projection view on the drone. In that case, you may need to select it as a shell clad, and it's not included in the bill of material. From here, you will need to define the clad thickness, the clad material, and the clad density. Okay, and if you have a horizontal vessel, like that vessel, okay, like that vessel, and in some cases, you may have a clad on just a partition on this shell, not around the shell. Okay, you may have a liquid inside this vessel. This liquid not increase a defined limit. So you don't need to fill all the shell with a clad, just a level, only define a level. So from here, you can add a clad level. So for example, here, let's add a clad with 1 meter height only to show you what I would like to say. And from here, when you click Start Assembly, the clad for this shell will be generated. As you can see, it's just a slice. It's not along the vessel. So if we take a section here on the vessel, let's take a section here. As you can see, this cladding comes only for 1 meter height from the bottom level of the vessel. Okay, it's not around all the sheet. So if you would like to make it around all the sheet, just remove this checkbox, and in that case you will get a clad along the sheet. By the same way, you can add a clad for the hemispherical head with negative straight flange. Let's add a clad for that head. So from here, for example, if you select this head from here and from elements, you can add a clad. So let's add left head clad. Okay, and let's select the clad and define the type of the clad. We don't like to include it in bill of material, so let's select the second type. Define the clad thickness, clad material, and the density of the clad. And by the same way, you can make this clad as a partition only, not along the head. So let's click on save and click start assembly to start creating the clad inside the head. Okay, and actually you will get an updated weight for the equipment because you have a clad here. This clad has a weight. So if you come back here to the bill of material table in SEG, you will find the weight here increased. So let's take a print screen here. As you can see here, the new weight after adding the clad. Okay, to check the weight before the clad, if we come back to the drawing again, so let's go back to the drawing. And by the way, here you can figure that the clad appears here on the drawing. So any change on the 3D model will be reflected here. Here we have the clad, and here the carbon steel thickness, like that. And the same on the head, you have the clad thickness on the head. Here you have the clad on the thickness. And here the thickness of the head. So we measure from here to there. That's the thickness of the head. It will be like that. Okay, and by the way, you can add a tag number, which is describe the item technical characteristics. Like this head, for example, that's the technical characteristics of it, or the description of this head. It's head with inside diameter. Like that, and the nominal thickness, minimum thickness after forming and cut. For example, for this shell course, here you have the dimensions of this plate. For example, for this flange, you can get a detailed description for this one as a 4 inches flange, weld neck RTJ facing with class 600 and scalable 80. So you can get a detailed description for items if you would like to add that by using a balloon. And from balloons, you can select part tag. Okay, or nozzle tag if you would like to add a tag for the nozzle. Like in that case, you would like to add a nozzle tag. So by that way, you can add a nozzle tag for this nozzle. Okay, let's come back here and check the bill of material. We are discussing a point here regarding the weight. So here the total weight of the vessel, and here the total weight of the equipment after modifying or adding the clad. Okay, so it's here you will update the weight of the equipment in case of adding a clad. Okay, for the welding details, as mentioned on here on those slides, you have many different ways to import a new item. It's not included in SEG, even it was on the 3D or on your drawing. Like creating an item for that sample, we create an item. It's not included in SEG library, and we discuss how to add it. On the second slide, we discuss how to add a sketch inside the drawing. So here, by that way, you can import your block from AutoCAD. So if this detail is not included in SEG, by another way, you can create. For example, let's create a new view or a draft view. Let's say weld detail 2. So in this welding detail, let's describe another welding detail not included in SEG. For example, something like that. you would like to add another detail or something like that, and let's add. After adding your dimensions, you can generate a weld detail like that. We add hatching like this, other hatching on that side. Let's make a fillet first. Here. And hatching. That, so you have here a new welding detail. For example, you can make something like that. So you are dealing with drawings like dealing with AutoCAD, but here you have a huge features and very powerful features. You can use it in your drawing. And the parametric modeling, you can use the parametric modeling, or you can use programming VI logic or the VBA. So you have many different ways to generate that. Here, as you can see, for the nozzle projection in SEG software, we have an option, or a calculator gives you the ability to calculate the projection of the nozzle. For example, here for that nozzle, okay, as you can see, if we, which is, let's say this nozzle, which is N1, if we come back to the model here and select nozzle N1, you can make a search here on this tree. So let's select N1, copy N1, so you can get N1 from here, okay? And from N1, you can open the calculator tool to calculate the projections, the required projection of this nozzle. So if you would like to modify on it, for example, here we would like to modify the projection to make it 3,500, for example. Now, if you click on calculate, now the projection outside the shell will be calculated automatically from this form, and it will be reflected. Here, if we take a print screen here, so as you can see here, we have a value for the projection. Another value here, and let's increase the thickness of the line. You have here a value, which is the calculated projection, and this value will be reflected here. So this value will be copied to that value, and automatically the 3D model will be updated. Now, if you accept this value and click on save, as you can see, this value will be updated. Now, when you click on Start Assembly, the forged hub for nozzle N1 will be updated. Let's take a look to this forged hub. Now, let's remove the half section. Now, we change the projection of this nozzle. If we come back to the view again, here we have this nozzle, and if you measure the projection or from the that side, as you can see here, this nozzle projection changed automatically, and the value will be reflected to your model automatically. So we help the user with professional tools because we are focusing on fabrication, focusing on detailing. So we generate many different options to help the user to generate the item in a correct way. One more option regarding the forged hub detail, how to create it in SEG. You can make that on a separate drawing like we did on the saddle detail. Here we generate a saddle detail. And if you would like to include it, for example, if you would like to include it on the general arrangement for one of or two nozzles, let's take a sample for a forged hub on shell, okay, like the forged hub of nozzle N1, another forged hub for nozzle on head, okay, and another forged hub with a helicide nozzle on shell. Okay, so let's take 3 samples. So here, let's open this hub. Okay, we have this forged hub. Let's close this one simply. And here we have this forged hub, and we would like to make a drawing for it. Now let's place the view of this forged hub. Let's change the scale. Let's make it 1 to 15, for example. Okay, and let's move it here. Okay, and let's take a look from the top view like that, and let's delete this view. Let's delete this welding details that we have. And from here, let's take a half section. So you can make a section like that, but this section will indicate one direction only, not the two directions. You can see you will get one hub height, but actually you have a different hub height around the nozzle. So to indicate the maximum and the minimum hub height, we will need to make a quarter section. So from here, let's create a quarter section for this one and make it as aligned. Okay, so by that way, you will generate a section, a quarter section for this forged hub. And from here, you can indicate the hub height on that side. That's the hub height which is described on the mechanical calculation. Okay, as you can see here, if we come back to nozzle N1, sorry, which is nozzle N1. Here, that's nozzle N1. Okay, so that's the hub height. So you can measure the hub height from here. Okay, and here the hub thickness. So from here you can measure the hub height. That's the hub height at the minimum point, and from here you can measure the hub height at the end. We can make a quick sketch here to indicate the intersection point for this one with the head, like that. So as you can see, you can make editing on the drawing, adding lines or something like that to describe something you would like to describe. Here, the highest point of the hub, the maximum height of the hub. Here you can define the inside diameter of the hub, the end thickness of the hub, like that, and the bevel height. Okay, all of that you can define it, and it suits the value here. And you can make a welding preparation for this one. For example, in this one, if you would like, as discussed, if you would like to make a chamfer, for example, you can make a chamfer for this nozzle. So let's select to make it with 15 degrees and the distance, let's say 95, and select this edge. But as you can see, you can make a chamfer in one side. And if you would like to make it in two sides, for example, so let's make it 60, like that, 60 millimeters, and make another one with 30 millimeters. So let's select this edge. So you can make a double V chamfer on this hub. So, and as discussed, you can generate a J coding or send this 3D model for the fabricator, okay, to avoid missing some information, because here you have the actual dimension and the 3D model for the forged hub. Actually, when you come back to the drawing, the detailed drawing will be updated based on what you did on the 3D model. Now let's check another nozzle, like the helicide nozzle on a shell. So let's select one of those forged hubs. Let's select this one, for example, and let's open this one. Here we have this forged hub, as you can see. Let's create a detailed drawing for it. So from here, let's add a base view for this forged hub, and let's modify the size. And this one, let's make it 1:10, for example. Like that, and let's move it here. And now let's take a section on that one. So let's take a long section on this forged hub. It will be like that. So if you measure the arc length on that side, it will be, it looks like that one. So let's open one of the, that's a drawing I created to check the dimensions and the locations of nozzles. If I import it in the right way, looks like your drawing or not. So it's just a check drawing. Here, as you can see, here, the arc length from the tangent point here, from here to there, it's equal that one. And if you take a section on the other direction, which is that direction, you will get the same value of the lip width around the hub. Okay, now by the same way, if you would like to make a chamfer here or there, you can do that for the forged hub, and it will be reflected automatically to your drawing. And by the way, here, after creating a section, you can add your dimensions, like the forged hub thickness, the inside diameter, the outside diameter of the hub, the end thickness of the hub. And for example, if we check one of those nozzles, like UG1, for example, here you can select the suitable type. Here you have a list of nozzles. Okay, so you should select the suitable type of nozzle. More than 30 types of nozzles available on shelf, so you can select the suitable type of the nozzle which suits your requirements. After that, filling the data. The same thing you can do it with any other item. For example, here for this type of head, for example, you will find around 22 types of heads, dashed heads. But you need to select the suitable type for your case. For example, here in SEG, you can make an ellipsoidal head as a half of ellipse. You can make an ellipsoidal head with crown and knuckle radius, and the crown radius value will be according to this equation, and the crown, the knuckle radius will be according to this equation. A flat dashed head, standard type head, and here you will find the values. And if you would like to modify it manually, like controlling the crown and the knuckle radius manually, you can do that by selecting the suitable type which suits your case. For the hemispherical head, for example, you will find a hemispherical head with a straight flange, which suits division 1, like you have a straight flange with a positive value. But in case if you have a hemispherical head with negative straight flange, okay, you have a cut on the head, you will find 3 different types to suit your cases. The first type, which is a hemispherical head with negative straight flange, as you can see, if we take a print screen here and take a close look, here you can figure that the center line of the thickness of the shell meets the center line of the thickness of the head. Okay, so both of the extension of, if you extend the outside and inside diameter of the head, so the thickness here of the head will meet the thickness, the mid thickness of the midline of the thickness of the shell. So in that case, the straight flange, this straight flange will be calculated automatically, and the head inside diameter will be calculated automatically based on the shell thickness and the head thickness and the inside diameter of the shell. Okay, so those values will be calculated automatically based on the thickness, head, and the inside diameter of the shell. Another type of head, which used in our case, in that case, which is a hemispherical head. We take a print screen here and come back here and print this one. And if you take a look at that view, you can figure that the straight flange, in that case, you can modify it manually. Okay, so we give you an option to control the straight flange, but in that case, the thickness or the midline as the thickness of the head not meets the thickness. If we extend a line, for example, from here to there, let's change the width of that line. It not suits the line at the thickness of the head. You can figure that because you have the ability to control the straight flange thickness, so the center lines will not be matched in that case. Okay, so that's another type of hemispherical head with negative straight flange. Another type of hemispherical head with negative straight flange, which suits the Y joint connection. Okay, so this type, as you can see, it's not looks like the others because it's connected to a Y joint. So you should be care about the items that you select to suit your needs. Here, if we come back to this, we use this type of head with the Y joint in that case. Okay, as you can see here, we use this type of hemispherical head, type B, and connect it to the hemi or the Y joint connection. I think now we may cover some of the important points related to the received drawings from your side. And by how to generate the 3D model, how to add non-standard items to the model, how to generate a sub-detailed drawing, and we make that with the saddle detail and modifying it by adding fireproofing Eclipse, how to generate a forged hub, how to edit on it and measure the distance of this forged hub, and you can use that to generate a G coding for that. We discuss some other important points like the development, the surface development for the inside surface and the outside surface of the vessel. If we have a large thickness, we should do that, not only one. And that faces the 3D model and how you can detect that easily on the 3D model and how you can export 3D PDF for your model. And we discuss how to generate the general arrangement drawing. And finally, I would like to indicate that SEG software can do a horizontal and tilted pressure vessels, vertical pressure vessels, SEMA heat exchanger, and storage tanks with fixed roof, and columns with different diameters and the transitional sections. You can make slug catchers, spherical tanks, and ducts. SEG software is the only existing software can do all of this stuff under one umbrella. Now, if you have any questions, we can you can ask them, inshallah. We can help in that.
Hi, Hegazy. Thanks for explanation. There are few points. So far we have discussed regarding this creation of drawings, all fresh drawings. But what about this revisions, further revisions, like in subsequent revisions, we include the revision triangle and clouds. So is there any provision to include this?
Okay, in Autodesk Inventor, this option for adding a cloud, it's not an option, but you can use another tool from Autodesk, which is Autodesk Design Review tool. This tool gives you the ability to add a cloud, revision mark, stamps, all of that to your drawing. For example, let's export this drawing to DWF. So from here, let's export the drawing. So from drawings, let's export the drawing to and select the suitable extension, which is DWF, and select the location. I will show you how to do it by using that and how to make a revision mark on the Autodesk Inventor drawing itself. Okay, I will show you two different ways to do that. Okay, so here let's export the drawing as GA, as a DWF extension, and now let's export it as a DWG, IDW. So from here, let's open this drawing by using Autodesk Design Review tool. So now you have this drawing here, and from the marks you can add clouds. For example, you can add a cloud here if you have a change on this one, like that. Like something like that, you can add a cloud, like a cloud here. Or if you have a table and you make some changes on size, for example, you have a cloud like this, and you can add a revision mark. For example, if you would like to add a mark, like revision 1. So by using this tool, you can make an advanced modified drawing or a marked up drawing like that to show your client where is the changes. Another way you can do it on the Autodesk Inventor drawing itself by creating a block as a sample. So let's create a new sample which indicate the revision mark. By the way, I forget to inform you something about the standard blocks in SEG drawing. I will discuss it after showing you how to create a new sample. So let's add a new sample. So from here, let's add a revision mark. So let's add a rectangle here and make this line as a horizontal line. Let's add a text. So it's rev1, for example. Define the size and make this one at the middle. From here, let's select this one and change size 4 and make it like that. Let's remove the bold. Now we have this mark, and let's save it like that and with 1. Now, if you would like to import this mark here as defining a block in AutoCAD, now we define the block. Here it's available here, so you can include it in a place that you would like to include. You can control the scale of this one, so you can change the scale, make the scale be like that. For example, you can control the orientation of this one if you would like to rotate it 45 degrees, for example. So you can make many things like that. By the same way, you can make something like the cloud and give it another color by adding it on another layer. Okay, so you can use that on to define the revision at that one. And here, if you one more point regarding the updating of the bill of material and the nozzle table. For example, if you on the next release you add some other items, okay, and here you have some updates in the bill of material and the nozzle table. If you add another nozzle or delete some other nozzle, how to reflect that to your drawing? Here, an option for that, which is when you select the drawing from tables, you will find this checkbox. Okay, this checkbox will give you the ability to update the old drawing in your the old table in your drawing. So if you would like, for example, if you would like to modify the design data table, okay, only, so you will select this this is checkbox, and now the design data table will be modified. Now let's check that. For example, here let's deselect all of those checkboxes and just select some fields here and click save. Now we would like to export those values only. Now when you click on create drawing, and from the tables, let's remove all of those tables and select the design data table only, because we'd like to update this table. We have a change in this table and we would like to update it. And from update tables, when you click on create drawing, you will figure that the design data table here, which is the only table, will be modified based on that. As you can see here, the design data table data will be removed and refilled again with the updated information. The same thing, you can do it with the nozzle table and the bill of material table. That's from release to another release. I hope I covered your question.
Yes, thank you. My second question is like for center of gravity.
Yes.
In PVLite, we get it along only one axis.
Okay.
But is there
here in
yeah.
SEG and the 3D model, you can get the center of gravity, the actual center of gravity, which will give you the ability to locate the lifting lugs and the trunnions in the right place. Here, let's check that. So let's check that here from that view. For example, you would like to locate the center of gravity here. So from here, let's select this view, and from this list, you can click on center of gravity. So it will appear here. That's the center of gravity, and by using the blocks, pre-built blocks in SEG, you can add the center of gravity. And if you would like to measure the distance from this trunnion, for example, to the other trunnion, here, as you can see, there is a little bit differ between them. It's not a huge value, but as you can see, that's the actual center of gravity. And for the other view, when you select this view, for example, and right click on this one, and the same thing, select the center of gravity. As you can see, the center of gravity is on the left bottom quarter, but it's not a huge space from the visual center line. As you can see, you can detect the center line from here and the center line from there. It's just some little millimeters. It's not a huge value. Okay, so you can indicate or define the center of gravity on the model, and that will help you to locate the lifting devices on the right place.
Right. Okay. The third point is like this 3D model can be used for further evaluation, like for weight, volume, or any FEA analysis.
Sure. We, as mentioned here on that slide, which is why we are using a CAD software, okay, which is that one.
Okay.
Here, by using a CAD software, you can generate any items you would like to add it to your model. The second point, which is the ability to make a finite element analysis, make a dynamic simulation, make animation, and all of that. And I will recommend you to visit our channel here, and you can find some of tutorial videos. One of them, which is showing the user how to make a finite element for a simple air receiver after creating it on an SEG software. Okay, so let's skip this one. And from here, after generating the, sorry, okay, here for this air receiver,
So like, for example, if instead of the full model, if I want to take a part of this model for FEA analysis, that also can be done?
Okay, but a complete model for finite element analysis, you will need a huge machine to do that. You millions and millions of nodes. So you can study for a huge models like that. You can study a piece of it. You can make a cut for a piece and study it separately. But study all of that, and the software itself of the finite element will not accept that. You will have millions and millions of nodes. I hope this point comes clear.
Okay.
You can do that, but you have a super machine to do that. Okay,
but we can't suppress the remaining parts. Like
you can do anything.
Can only
you can do anything. You are dealing with a CAD software, so you can take a copy from some assemblies. You can make a modification. You can make another project for studying analysis only. Okay, you can do anything you would like to do. Okay, so in that case, we make a simple vessel by using SEG software. After that, importing it to the finite element tool in Autodesk Inventor, and adding the boundary conditions like adding internal pressure, adding the fixation point, all of that, and define the mesh of the element. After that, creating the finite element. Besides that, you can make a lifting procedure for your equipment, and we, if we, for example, here by using the SEG helper, you can make a lifting simulation study like that. That's a vacuum tower. We used the SEG modeling tool. Sorry, may I have a problem with the internet? The loading is not.
It's okay, fine, no problem. There is one more point. For example, along with any dimension, can we add some annotation to those dimension values?
Yes, sure. As mentioned, you are dealing with a CAD software, so you can do anything you would like to do. For example, here you have a dimension like that. If you double click on it like that, you can figure that the value here is not, you cannot change it. Okay, you cannot change it unless if you select a hide dimension. So in that way, you can modify the actual value. But if you would like, we don't recommend that. Actually, we don't.
No, I mean to say is that if
let me give me a minute, please. But you would like to add another text to this value, like adding the can 3, okay, like that. You would like to add a text like that. Okay, so you can add a text like that value. So anytime you change that value in a real model, it will be automatically updated here. If you make manual modification, which is hide the value, now you will not be able to reflect this value in your model. So if you would like to add a text, just add a text like that. For example, the straight flange here, if you would like to add a straight flange like that, so it will be reflected here. If you would like to add another one on the other side like that and make a match between the changes here and there, just copy properties and make it looks like on the other side. You can add the inside diameter for this vessel. So from here, let's add a text like let's add carbon steel, carbon steel I E equals So that's the carbon steel inside diameter. So you can move this dimension here, and here the carbon steel thickness, for example. So let's move this out. So from here you can edit the text like carbon steel. That.
Okay, that's fine. That's what I was
Hello?
looking for.
Hello?
One more thing I would like to indicate here. For example, for this flange, you don't like to add the hidden lines here for this flange. You can see that it's a huge number of lines, and I don't need it. Okay, so this item only you would like to make it as a visible line only, not including any hidden lines. So from the tree itself, if we decrease or collapse this tree, you can get this view from here. So we will find this view from the browser. And from here, we would like to change nozzle N1. So from here, for example, for let's say M1. So that's nozzle M1. And here we have that's nozzle. It's not nozzle M1, sorry, it's a nozzle M3. So for example, here that's nozzle N3. So you can hide the lines of this item. So if you select hide lines, all the visible hidden lines will be disappeared. The same thing you can do it with the blind flange like that, so you can hide all lines. And the same thing you can do it with the stud bolts or the davit.
Okay.
Okay. So you can make many. Okay. Go ahead.
So it can be done at element level and at global level also, right?
You can make it on global level or on item level.
Okay,
so if you would like to control it in global level, you can control that from here. As mentioned, you can make the view with hidden lines visible.
Yeah, once for all. Yeah.
Okay. So for example, we would like to change the view for as a visible line, and here we would like to make a shading. So when you let's remove this checkbox from here and click on create drawing. So you will find here that view will automatically change it to visible lines only. So no hidden lines appear here. Okay, and it's shaded now. You can see the color will appear. Sometimes you may need to make that, and sometimes not. So from here, let's remove the shading and make the lines, the hidden lines visible again. So when you click on create drawing, so it's on the visual level itself, so you can control that on the visual level.
Okay. Just one last question.
Yes.
If in case we need to share this 3D model to our client for some confirmation, some clarification, that we can do it by exporting to 3D PDF?
Okay. Here you can do many things. You can export it in AutoCAD 3D. You can export it in 3D PDF. As mentioned here, if you would like to export that, the drawing and the 3D model. Here, for the 3D model, for example, you can export the 3D model. And you can, by the way, you can define a views, like if you would like to define a clash view here, another view. So you can add the views that you would like to focus on it with your client. So you can define it, add it here. After that, you can, from file, you can export and select 3D PDF. So in that case, the 3D model will be exported in 3D PDF file, like that file. So you will get that PDF. And by the way, here on the 3D PDF, you can make a banning, make a rotating, and you can hide elements. For example, for that item, you can make a hiding for elements from this list if you would like to hide some items. Like, for example, let's extend the view again. Sorry, let's come to the default view. For example, if you would like to hide a level, left head, here you have this left head. You can hide this head, or you can hide the segments inside this head, because this head created from segments. So if you would like to hide one of those segments only, you can make that from the 3D PDF, or hide another segments like the mid segment, that one at the middle. So you have the ability to control all that. Besides that, you can make 3D nodes and measure dimensions. For example, if you would like to measure some dimensions in your model from the PDF, okay, so you can indicate that by measuring a dimension like that. Okay, so you have a length, and if you would like to measure the length of that one, so you have a length for that one. You can add a 3D comment. For example, here you would like to add a comment here on the trunnion, for example, because it's in your drawings, it's include an end plate. By the way, you can do the end plate, but the option of adding bolts on the trunnion, it's not included. So let's add a comment here. That so you have a 3D comment in your model. So if you send that for your client, actually he can detect what you would like to say. Like as mentioned, you have a clash here, you have another clash here, so you can take a decision based on that. Another thing, you can export the 3D model in many different extensions. For example, if you would like to export your model in AutoCAD 3D or another extension for
like
the CNC machine, yes.
IGS or STP
yes,
files.
yes, it's step file or
Okay.
STL file. So from here, when you click on the vessel node from the tree, you will find export to. And this tool will give you the ability to export this vessel in PDF, IDW, step file, STL, IGS file, SAT file. So from here, let's select AutoCAD, for example, AutoCAD DWG file, and let's select the same location. And from here, let's
just a minute. Just a minute. Can you come to this one extension, please? File extension.
Yes, okay. It will take a minute to export because now it's processing the exporting. After exporting, we can check. I think it's exported now. So you would like to check another extension or something like that?
Extension, yes.
Yes.
Creo is supported. Creo part file.
I don't know what is the extension of the Creo, but Creo can
that
read
is
this
dot PRT.
I think
okay,
it's not included, but you can read IGS file, SAT file, STL file.
That's fine. Okay.
You can read that. Okay. So here we have an exported AutoCAD drawing. So let's open this AutoCAD drawing with BricsCAD, for example. So open with BricsCAD or AutoCAD. Here we have the 3D model of the equipment. Okay, we export it in DWG extension, so you can open it in BricsCAD or in AutoCAD. So as you can see, we have this 3D model. And by the way, here one of the most important things in that part, for example, here you can figure that in that 3D model that you have, you can prepare a drawing on AutoCAD based on the 3D model if you would like to make that in BricsCAD. For example, if you would like to for a view, for example, let's import views, so mechanical. Let's make a base view for entire view and select layout. Okay, so you can, sorry. Okay, so let's, because it's a huge model, it's a little bit takes time to generate the view. But by the way, here by SEG software, you can export to many different extensions.
Okay.
As mentioned.
Any one of us having any query further? We can discuss over here.
Hitul, go on.
क्या सर?
कुछ है? Any doubts?
नहीं वो सर आई लॉजिक का तो खुद ही करना पड़ेगा ना हमको.
Ahmed, just a quick one. I mean, if there is any non-standard, so if the iLogic is not defined by the tool, then we have to create it, right?
Yes, as mentioned, if you have a non-standard item, if you would like to generate it by hand or make an iLogic tool to modify it, you can do that.
Yeah, there's an option is there. He has shown it initially.
Just tell me a quick one. How long it takes to make this model, Ahmed? I mean, modeling, detailing, everything for a vessel of this size.
I mentioned that on the slides here.
Sorry, I was.
Slide, for example, for this vessel, actually, it takes around 5 hours studying the drawings and extract the data from it. Like, for example, I would like to make a nozzle. So, what is the nozzle name? Where it's located on any shell, and the type of this nozzle. It's a forged hub with lip, or it's an integral hub with lip. So you can first, at the first point, define each nozzle or each item. I am talking in general, each item dimensions, and write it on a separate paper. Okay, so that's the time consumed in extracting data or collecting data from your drawings. Actually, I consumed I think between 3 and a half hours to create the 3D model for this equipment.
Okay.
So if we are talking about a professional one and another one start in SEG, I think this time you can double it if the user has the first time using SEG. He just will need to decide which type he will need to select to give him the good result. As discussed for the head, for example, this hemispherical head, you will find 4 types of hemispherical heads. Which type suits your case? So you would like to make a hemispherical head with negative straight flange. Don't go to and select ellipsoidal head. So you should select the correct or the suitable type for your case. You would like to make a forged hub with lips as a helicide nozzle. So don't go and select a nozzle from pipe or a nozzle from plate. Okay, so here that's the difference between the professional one and non-professional one. Here, you may take some time to decide which type you will select. For this other video, around, I think it's less than 3 hours for collecting data, and between 2 and 2.5 hours to generate the 3D model on SEG. And by the way,
to do the detailing of all the sheets, how long it will take after the model is done?
It depends on what you will need to generate. As mentioned, here, for example, we generate the general arrangement drawing. Okay, you can add all of those tables, by the way, generated automatically. Let's say it takes 5 minutes to fill all of those tables and add the views. Okay, and let's say you may take
just a quick one in between. Whenever there is a non-standard item which was not part of this SEG, okay, when we do a separate iLogic, how does the bill of material appear for that particular item? Will it come in the same sequence or how it is?
Okay. Now let's add the created item which I created manually for that clip. We create this part, okay, and during the session we discuss how to create it.
Yeah.
Okay. Now, but actually it's 3 parts. It's not 1 part. But for saving the time, I create it as one solid. But if you would like to make it in a correct way, you should create this weir plate as a separate part, create this clip as a separate part, and that one as a separate part. But actually, if you would like to add that in SEG bill of material, now you have an option to do that. You can add an extra bill of material. So you will get this list and select the vessel from here. For example, you have 6 items from add the description as platform. Okay. And the description, it's a plate. Well, let's say 300 millimeters with 160 with thickness 10 millimeters, and the material is a 36, and the weight is half kilograms, and the part number, let's say 1. Now, when you click on Save and Update, it will appear on the bill of material. Let's come down here. You can figure that you have a platform clip. It will appear here. And if you export your bill of material, it will be exported to the bill of material. If you come back here and update the table of the bill of material, it will appear here. So by that way, you can add the external items to SEG bill of material to make it appear on the final drawing bill of material. And as mentioned, if you export your bill of material, you can make some modifications. If you would like to make some modifications, here are the views on CAD that we did. It takes a long time. Okay, so let's come down here to the what I would like to. Yes, the bill of material. Here, the bill of material. You can send this file to one of your colleagues in another department to prepare some orders for purchasing or something like that. And by the way, you can modifying on that if you would like to modify something or edit something, and coming back here and update it or reflect it here by pasting the modified values on that table. If you would like to make something like that, but we don't recommend making that. We recommend making everything from SEG software.
So that I mean revisions can easily.
Actually, I have a question regarding the consumed time, because I have a long time working with the AutoCAD, and I have a deep experience in AutoCAD and Autodesk Inventor, and I'm an Autodesk Inventor certified professional. And I would like to know what is the actual time consumed from the draftsman, if you have one draftsman, generating the application drawings of this equipment. Let's say he will get the mechanical calculation from the designer. After that, he will collect the data from the mechanical calculation and start generating the.
It will take 3 working days, Ahmed. It will take around 3 working days, 3 to 4.
Are you sure? Because yes. I think all of those drawings may take a week. 6 or 7 days.
You can say normally 1 week, including detail, no?
Yes.
Maybe a week.
Yes, I'm talking about everything, because here you have all of those values filled manually.
Yeah. Maybe a week's time you can take, Ahmed. A week's time.
But here, if you create a nozzle, automatically those values will be generated automatically from SEG. But here, every table you will need to fill it.
Yeah.
So if you would like to make it feel like that, so you will need to make a sketch. After that, make a trimming and extend a lot of orders. You will make it. So actually, from my side, I'm as a professional in this area, I think it's from 6 and 7 days, maybe more if you don't have a professional draftsman. Maybe more than 7 days.
Ahmed, tell me one thing. Have you ever got a query from any of the users who is using this tool, which you are not able to incorporate or anything? I would like to know about the limitations as well. Like, is there any limitations where some query has come and you couldn't incorporate that?
सर मुझे एक क्वेश्चन है.
हाँ.
सर ये अगर हम फैब्रिकेशन ड्राइंग पूरा इसमें बना देते हैं, बराबर है, उसके बाद में अगर कुछ क्लाइंट का कमेंट आता है, मीन्स कोई भी एक बीच का एक नोजल है जिसमें उसने 2-3 पार्ट ऐड कर दिया, पाइप ऐड किया इंटरनल, या फिर कुछ भी ऐड किया जो उसके रिलेटेड नोजल के रिलेटेड रहेगा, जिसका ऑलरेडी बिल ऑफ मटेरियल बना हुआ है, तो वो जो पार्ट नहीं, हाँ वही, वो जो पार्ट ऐड किया उसका बिल ऑफ मटेरियल में वो जो हम पार्ट नंबर देते वो कैसे इंक्लूड होगा अंदर, या लास्ट में होगा या फिर बीच में होगा?
ठीक है. Ahmed, what the question is, like if there is one particular nozzle, let's take N1, okay?
Again, please.
Sorry, I mean just a question on my colleague wanted to ask. If there is a nozzle, for example, let's take N1 nozzle, okay? You have a hub and you have a flange for that, okay? 2 components are there right now. So in case, because of the increase in projection, we don't want to increase the projection of the hub. We want to add a small pipe in between, for instance, okay? And how will that change reflect in the bill of material from the previous revision? Will it be, for example, if this part number is part number 10 and 11, will that in between part will be added in between, or it will go to the end? How exactly it adds up in the bill of material?
So let's make it step by step. Now let's go to the N1 nozzle, and let's increase the projection to 370, for example. Okay. And from here, we need to, if we come back to the 3D model, here it's let's increase 200 millimeters, and from here, sorry. we will measure the height of this flange to take it in our consideration. Here, that's the height. Okay, and so let's open that calculator and let's let's pick that value 214.13 plus the pipe length. Let's add a pipe length with, let's say, 400 millimeters. So the total length after the hub will be with that value. Okay, the total length for the pipe and the flange after the hub will be with that value. So let's come back to SEG calculator tool and change the projection and add the extended length, which is the extended pipe and the flange, and recalculate that. So I think we may need to increase that up height a little bit.
Ahmed, I think there is a slight correction over it. That projection is in terms of one separate item, like one separate part is being being inserted into this in between the hub and the flange. So how
yes,
that additional part will be reflected?
Would you mind? Would you mind to give me 2 minutes to?
Go on.
Yeah. Please go ahead. Yeah.
Please give me 2 minutes to clear that for you. Okay, so let's let's increase that one and let's add 500 millimeters for the pipe only and recalculate the hub projection. So let's decrease this value a little bit. So let's make it 700. And here we have a pipe between the flange and the hub, like that. Now we need to add, if you take a look to the nozzle N1, if you take a look for this one, the flange is directly connected to the hub. And now we would like to add a pipe between the nozzle and the flange. Now, so from here, let's select a new pipe and let's make it as N1 pipe. Okay. So you will get a pipe here on the tree for nozzle N1, which is that pipe. So let's define the pipe size. If you select the nozzle, for example, you can figure that it's 24 inches with end thickness 24. Okay, so in that case, if you would like to make this pipe from plate, for example, as a pipe from plate with 24 inches, or from pipe, so you can select a pipe and make a user-defined thickness for the pipe, or you can make it as a shell plate, so you can define the inside diameter for this one. So from here, let's define the thickness first, and to calculate the inside diameter of this shell, it's like that, and 48 the thickness from the two sides. So the inside diameter of this shell can be like that. So that's the inside diameter. And here the longitudinal welding line orientation, and here finally the length of this pipe. Now we define this pipe. But if we create it, it will be after the flange. So if we create it on Autodesk Inventor, it will come here after the flange. But we need it between the flange and the hub. So how to do that? You will come here and you can move this node, right click on it and move it before, okay, and select N1F, which is N1 flange. So in the tree, in SEG tree, as you can see, now it's modified. The nozzle, after that, the pipe, after that, the flange. Okay, so we modify it on SEG tree. Now when you click on Start Assembly, it will be modified on the 3D model. Now the hub height will be changed. And here, as you can see here in the 3D model, you will get a pipe from plate with a welding line. So if you would like to open this part, for example, and get the sheet metal development for it, you can get the sheet metal development for this part.
How the bill of material changed, Ahmed? I want to see that.
Okay. Now we have a new part here. If we check the old bill of material in our drawing, as you can see, we have 130 items. But here in SEG, after opening this one, let's delete the last item which we added manually, which is the platform Eclipse. So to make this point clear, so open this one and let's delete this item because don't make any confliction. Here we have 132. But here on the drawing, it's 130, okay? Because we add some other items here. And if you check the list of elements, you will find here one shell course. Here it's mentioned here. Let's take a print screen. We have a new item here, which is the shell course, and here's the description of this shell course. Okay, it's with inside diameter 562 millimeters and with thickness 24, and here the length of this item, and here the weight of the item and material of this item. So it will be, so why it comes on this arrangement, why it comes in location number 4 or item number 4, why it's located at top, because we in SEG we have a group number for the priority of items. We have the formed heads as the first priority. The second priority is formed blades as a shell or a seamless pipes. And after that, the forged items, fittings. So we have a priority. So the priority, if one item increased on one of those priorities, it will move the item number, and you can update that in your drawing by clicking on the update item number option, which is that one. This button will update the item number to make it suits the bill of material. For example, here we create a saddle detail drawing like that. We create a saddle detail. As mentioned, this number, for example, which is 74, if you check it with the bill of material here, which with this bill of material, you will find it the same with that one. Okay, which is 72, which is that one. Okay, but if you make any update, you will need to make update item number to reflect the new item number to the 3D model in your drawings. Okay. I will show you some real samples created by SEG software. Some of them for heat exchangers, like that. Okay.
But the bill of material part is still not clear. It is actually, it should have been added in that bill of material section of that nozzle, but it has gone to the upside, no?
Doesn't matter, no, Zaid, because the part number will be defined, right, for that. So wherever it is, the part number is already defined, right? It will come as part number 4. Maybe it not be in sequence.
Yeah, because normally we categorize this, no? Nozzle N1, all the related part, nozzle N2.
Doesn't matter.
But it will be listed there in the as well.
सर देखा उसमें बिल ऑफ मटेरियल भी पहले सेल आता है, फिर पाइप आता है, मींस सबका ऐसे सीक्वेंस आता है. हमारे हिसाब से सीक्वेंस नहीं है वो.
It's okay, doesn't matter, no. Only thing is we should see it. The thing is, it should be captured in the drawings with the proper part number. That's it. That's what it matters the most. How it is, yeah, I mean, because they categorize it in a plate pipe in a different category. You know, might be that will help us when you create an MR. If you want to create an MR from this directly, you can take. Yeah, it is categorized into the same this one. No.
Yes,
but sir, हमारा फिर format में format के हिसाब से नहीं रहेगा.
Our format anyways,
we'll see.
That's okay.
Okay.
Yeah, Ahmed, you were saying something. Sorry. Yeah.
Okay, no problem. Do you have any other questions?
Yes, there is one more question from my colleague.
Yes, sure.
Like in case of external helical coils, like limpet coils, which is coming on the vessel exterior vessel wall, so we can model that coil in this this 3D.
Okay.
Like half pipe coil.
Yes. If you would like to model it in Autodesk Inventor by using the Autodesk Inventor tools, you can do that. And in SEG, the previous release, which is version 5.3, we provide that. And if you can come here and watch our updated videos for that one. One of them for the coil on centric and eccentric cones. And we could open it from here. Sorry. For example.
Ahmed, you didn't answer my previous question. I mean, were there any queries you have got from any of your users which were not able to create?
In SEG, yes, you may have some items not included in SEG. As mentioned here in your model, some clips or some clip configuration is not included. So you can do it by using Autodesk Inventor.
Like from
if we have a request for some items, the last request from a company from Japan, Takada Corporation, they asked us to include the GIS standard pipes and for hot rolled sections, pipes, flanges, and fittings. And actually, we submit some of them on the previous release. For example, here, if you select the can, for example, here you can figure that we have the GIS pipe standards based on their information that they submit for us. We find a list of standards here for a pipe which is defined by nominal diameter and scalable. There is another type of definition which is nominal diameter and thickness, and here's some other GIS standards depends on that. Another standard for GIS which is defined by outer diameter and thickness. Other parts we mentioned here for that, like one of our clients asked us to add this type of lifting lug. Actually, now it's available for all of SEG users. One of our clients in Korea, this tank company, they asked us to add this type of support leg for the spherical tanks, and they submit the information for this one, and we generate it. One of other things, which is the some of the other things we submitted for a company in India, this type of the davit. Okay, so we have a different types of manhole davits, but they submit a spec for this davit, and they asked us to make or generate this in SEG software. So we include.
So how does it work, Ahmed? I mean, for example, this kind of queries usually come for us as well, because most of the end users has a different standards of davit, even if they might be small, but it will be a different. So how long does it take for you to generate for us and give in case if there is anything like this?
It depends on how much information we will.
Let's take an example of this davit only. I mean, the man-made davit.
This davit only may take a week from us, but it will be available on the next release. Okay, so
no, but how, for example, on a project, if at all we wanted some support, how exactly it works? You give us as an iLogic for that particular project, and then you include it in your SEG, or how exactly it works?
Okay, we discuss different options for this one. The first option, which is generating it from your side, okay, in Autodesk Inventor. So you can make a 3D model for this one by using Autodesk Inventor and add it to your 3D model and include it in SEG bill of material to make it appears in your drawing. That's the first option. The second option, you just make it on the drawing, just as mentioned here, as a 2D drawing. Here, if we come back here, as mentioned, if you would like to add a clip, for example, no need. If you would like if you don't need to generate a 3D model and consume a time in that, you can just add a view as a 2D sketch on the view, like that. Okay, that's another way to do it.
Okay.
One of the other ways, which is asking SEG development team to include this item to SEG library, and in that time we will need enough information from your side, like sending us a spec which include all dimensions of this, like here as mentioned for this manhole. Our client send us a detailed spec for this manhole, which includes the dimensions of based on the rating and the size. Okay, and we use this drawing to generate this one. And actually, we make an option for the other users. For example, if you have a size larger than 24, for example, let's say 32 or 38 manhole, how to deal with that? Okay, so we give an option here for each element we generated based on a spec. We give an option to give the user the ability to modify it manually. So you have the same configuration, but you would like to make another dimension. So here you can select on this checkbox and modify the values by hand. Some of those items, for example, as mentioned, let's add this type of the forged or this lifting lug, for example, like that. To add this lug, as you can see, it's you can select the weight based on this spec, you can select the lifting weight. So when you select the lifting weight, for example, 150 tons, automatically the values will be changing. But if you would like to modify it by hand, just select user-defined dimensions, and now you will be able to modify those values manually. You can add a cooler, you can remove it, you can add a split plate or remove it. So we give you an access to make different things to suit your requirements and the other customers' requirements. Okay,
but
don't focus on the spec itself. We make it common. Okay, so we make the spec, but we make it common. So if anyone would like to change on it, you can do that.
All right, fair.
Okay, regarding the iLogic, we providing this option, but it's a charged option. It's not for free.
Okay.
But if you make it in SEG, we offer that for free. So if you would like to include some items in SEG library, we offer that for free, and the other users will be have an access to make it. It's not only for you. So if you submit some item, so it will be available in SEG library for all users. If you would like to make it for you only, in that case, it will be charged. Okay. And by the way, if you would like to make something special, not in SEG software, like making iLogic model like mentioned in that one, by the way, we make it for Clever Prox in USA and Canada. We make something like that for them. They providing a automated 3D model for this steel structure. They have sometimes to change the height, length, the beam size, the beam standard. They make
like
it
a prototype,
HEA,
like
sometimes yes, they make it HEB instead of HEA. Make it IBE. So you have the so you will give us all of your requirements. We will study that. After that, we can proceed with generating an automated model. And from interface, you can modify that. Besides that, the drawing, an automated drawing with updated bill of material based on the changes on the 3D. Okay.
Anyone has any questions?
Yeah. Lastly, we would like to see that model with that helical coil, if.
Yes. Okay. Okay, I will show you that here. If we come back here for the updates, let's say for the conical head coil on the this one. Okay, so as you can see, you have an option to create a coil over the eccentric cone, and this configuration actually it's very difficult to create it manually, and you should have techniques of modeling to generate it in the right way. Okay, but with SEG we help you to generate something like that easily. One more thing we generated for the coil on head, for example, here. We submit two different types of coils on head. One of them you can control the back here and check import a coil. Okay, and you will find different options here. If you would like to make a beach on the longitudinal direction with equal spacing on the longitudinal direction, and if you take a look from the top view, you can figure that the coil on the head, because
pitch is variable here.
Yes. And if you there is another type which is equal spacing from the top. So if you take a look from the top, you can make the pitch equal at the top like that. So we submit those types for over the heads, and you can add items at the end, like if you would like to add an elbow at the end of this one. So as you can see, you can add an elbow here and there, and add any other connections like adding a pipe, a flange, a reducer, anything to those items. One of the submitted features, and one of the important features we submitted in SEG new version, which is shell from staggered plates. For example, here, if you take a look to this shape, as you can see, the reducer, so eccentric, and the shell, it's created from plates as a staggered plates. It's not usual plates. As you can see, you have some plates in some locations. Here in SEG, for example, if you have one case like that, you have a plate here, another plate here, so a complete plate at the top. So with the new version of SEG, you can make a shell from staggered plates. Besides that, you can generate an eccentric or centric cone from staggered plates. Here for the eccentric reducer, for example, if you would like to make an eccentric reducer, you will select that type and generate the eccentric reducer from plates by that way. Here you can see that the eccentric, you have segments, so you can control each segment separately in the eccentric reducer, and that option will give you huge flexibility in modeling if you have, and you can control each blade thickness, by the way, so you can make one plate with 10 millimeters, another one with 20, another one with 40, so you can control the thickness of each plate. Some other features for the internal ladders. We submit a new feature for the internal ladder of the inside the vessel by two different arrangements. So you can make it radial or make it with the longitudinal direction and control the sloping or the tilting angle of the saddle. You can make the sides of the ladder from blade or make it from equal angle. So you have many options to control that. So you, as you can see, you can make a ladder as a radial ladder or make it as a rectangular ladder inside the vessel like that. So each release we have some new features we submitted, some of them based on some of our clients, some of them based on our view, because sometimes we have a plan to add some items. If you follow SEG software from years, at the beginning we start with pressure vessels only. Okay, the second year we add the columns with different diameters and the transitional sections. After that, we add storage tanks with fixed roof. After that, we add the heat exchangers according to theme. Spherical tanks, ducts. Each year we have new modules we added, and in each module of those we add some new features, like as we discussed here on the previous release, we add many different features like internal ladders, shell from random blades or staggered blades, centric cone with random blades, coils on centric or eccentric reducer, coils on head with crown and knuckle, radius with two different options. We add the GIS standards of pipes to SEG library. So many different options in each release.
How often do you revise this SEG, this one, for editions?
Again, please.
How often you would do this revision of the tool, Ahmed? Like the new revisions, how often you bring? Every 6 months, every 3 months, like that?
Yes. Between 1 month and 2 months is between release and the other release. The release, it's an update, but version, it's a complete version. Release between months and 1.5 to 2 months. So we include the new features or new items in each release. Okay, but between the version and the version, we make a huge, like adding a new, for example, from release version 2 to version 3, we add a heat exchangers. So,
so that's the total.
Okay, but from release to another release, we add some items like internal ladders, coils, some types of lifting lugs, something like that.
Well, anyone has question? Hitul?
No, sir.
Yeah, that's all from our end.
सर वो उनका वीडियो जो YouTube पे वीडियो है उसका चैनल का हमें लिंक मिल सकता है उनको बोलो ना अगर चैट में.
It is there. They have already sent to us. We can see that.
I think Fauzan may
has already given us, yes. He's given
yes, send you a recorded video for this session, and you can revise
this recorded session also. I will share. Okay.
Fair enough, because I would like my other team members also to go through it once, so that even they understand the features, everything.
Okay. Okay.
And how about the support, Ahmed? I mean, yearly support when we have. So what kind of support is included in the package? Like, for small queries, like how do my team approach?
Okay. If you have an annual subscription, for example, along the subscription, you can get the technical support for free. So if you have any questions, or if you have any issues in a model or something like that, you can send us the file and we can review it, update it, or modify on it and send it back to you.
Okay.
Or suggesting a way to generate this part, or helping you to generate this part by some other ways. And besides that, if you have a request to generate non-standard item to include it in SEG library, it's so we offering that along the subscription period. If it's annual, along the subscription and technical support period, we offer that for free. But as mentioned, if it's for free, it will be available for the other SEG.
It doesn't matter. Yeah, fair enough. Yeah. Okay, I think that's
one more point. One more thing regarding this point, which is if you have a lot of queries, or if you would like to include a lot of items, we have another request from other customers. So we will make a schedule and we will inform you about this feature when it will be available in SEG.
Okay, fair enough. I think that's it from our side, Ahmed. Thank you very much for detailed review. That was really helpful for us to I think we already spoke earlier, maybe 2 years back. I'm not sure if you remember. 2 or 3 years back, we already spoke once on this. But I think the software was not so developed at that point of time, and I see a lot of changes happening right now. So it's good to see that. We will definitely, initially we will see how to proceed. I'll discuss with Fauzan and see how we can take it forward, Ahmed.
Inshallah.
Okay.
And thanking you for your valuable time, and for you and your team. And I hope in this session I covered some of your queries regarding SEG and modeling, and how you can deal with the non-standard elements, how to generate drawings, how to create or export the 3D model in many different extensions. If you would like to discuss something with your client. Finally, again, thank you for your valuable time. Thank you, Fauzan, for your
thank you.
Thank you all.
Yeah.
Thank you.
Thanks,
Fauzan. I'll be in touch with you, Fauzan. Thank you very much.
Yeah, sure.
Okay. Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye.
Thank you. Have a nice day. Assalamu alaikum.